All right. Hey, everybody. We're here with Jafar Husain. Jafar works as a technical lead for the Netflix UI. He is the architect of Falcor, Netflix UI data platform. He specializes in building reactive event-driven systems. A highly rated speaker, he's spoken at ReactConf, HTML5 DevConf, QCon, CodeMesh, Yao, and given Channel 9 interviews. He's also trained hundreds of developers to build event-driven systems in JavaScript. He's the Netflix representative on the JavaScript Standards Committee, that's TC39, and is actively working to evolve the JavaScript language. Go ahead, Jafar, take it away.
Hi, guys. Hope you can hear me loud and clear out there. I'm just going to jump into this PowerPoint presentation here and share my screen. Hopefully it goes off smoothly. All right. So, can everybody see that out there? Okay, let's hope so. So this is a presentation about the software Falcor. And before we get too far into it, I want to ask you guys out there a question, or really put something to you, which is that every user out there wants to believe that the entire cloud is sitting right there on their device, whether that's a mobile device, whether it's an iPad, whether it's at home, whatever device it is. It's our job to create the illusion that the entire cloud is just at their fingertips. But what if we could code that way? What if we could think about all the data out there on the cloud as if it was local? And how much easier would it be to program if we could think that way? So before we get too much into that, I'm going to talk a little bit about REST. Now, the idea here, for most of you who, I'm sure some of you out there who either use REST endpoints or feel like you kind of are comfortable with the ideas of REST, is that REST stands for representational state transfer. And originally, it came out of the practices that kind of worked on the World Wide Web. And so we started with a graph of resources.
Hey, Jafar, are your slides supposed to be advancing?
They are. I'm on the World Wide Web. Is that not coming out?
All I see is the PowerPoint, kind of the editing window.
You know what? I might have shared not the whole thing. So 1 second. This will just take me 1 second. I'm going to share the entire screen, and hopefully that will work better. And so,
oh, there we go.
So, everybody see that? Great. So let's talk about REST. So we have a graph of resources, the World Wide Web, right? And every resource has a unique identifier, and that's the URL. And then finally, we have verbs for transforming resource state. So we have get, put, post, and delete. Now, we at Netflix, a few years ago, we were looking at basically rebuilding our service layer. And, it occurred to us, hey, Netflix is a browsing problem. Why shouldn't we build our API as a REST API? And so this is sort of what we started out with here. And I'm curious how many folks out there had a similar sort of progression. We started out with a RESTful API. And so as you can see, we have entity and then ID with these slashes, which makes a lot of sense. And so as you can see, here's an example of a title resource, right? And so we have a little bit of metadata about a title that you can watch at a particular URL. Now, the important thing to understand is that when we went down this path, we really ran into a lot of latency, because if you think about how many titles are actually displayed on screen when you load up your Netflix gallery, well, it's quite a few. This is sort of what the progression looked like. First, we got the list of genres, and then we would get each individual title resource, the little JSON resource you just saw, and then we would get each individual image, and then finally, by the time I'm done, and it usually takes about as long as I was just talking right there, finally, we'd load the screen. And so it occurred to us that, this really wasn't very practical. Originally, the World Wide Web is designed for really large resources, and we were sending down little JSON resources. And as a result, this ping-pong back and forth to different servers really slowed things down. So what was going on? Well, if you go back to understand how we got here, 10 years ago or so, the web was once a place to get things. And now it's become something else entirely. It's still a place to get things, but it's become more. It's a place to do things. And the concrete difference, the way that manifests itself, is that if you think about it, web pages in the early days of the World Wide Web, they served small amounts of large resources. However, web applications served large amounts of small resources. So if you think about it, what happens when you use Netflix, or a lot of applications for that matter, if you just swipe your hand across the screen, you'll see maybe 100 titles fly by. And each one of those little resources might have just a few properties on them. It's really not practical to make a full HTTP request for one of those resources every single time you flick your hand. So over time, what happened is that our nice, clean, RESTful API became something else entirely. It became sort of like a REST-ish, REST-less API, where all of a sudden we were just passing these galaxy of URL parameters to the end of each URL. And really, at this point, it's not really REST anymore because we're passing a bunch of these parameters. We don't think of these things as resources anymore. Frankly, we think of them as procedures, right? We're calling a procedure and we're passing it a bunch of parameters. And I have suspicion, and I've seen firsthand, that a lot of the backend systems out there fall into exactly this pattern. And they basically end up developing a series of procedures on the server side. So RPC has some big advantages, though, right? Now I can write a specific custom endpoint for every single view in my application. And what that allows me to do is it allows me to make sure that I get all the data I need in a single network request. And that really cuts down on latency, which is so important for mobile applications. So here we see that over time, I'm going to collect up this proliferation of endpoints. As I add more and more views to the system, I'll add more and more endpoints to support those views. And over time, they'll get more and more parameters. And they effectively become no different than procedures, things that you call with a bunch of parameters, not resources per se. So why is this important? Well, one of the benefits of RPC is low latency, but one of the things that REST has going for it is cache. It's so easy to cache a REST endpoint. Why is it so easy to cache a REST endpoint? Well, every single individual resource has a unique identifier, which makes a natural cache key, and that's that URL. But as soon as I start building these quote-unquote resources, which are really procedures, that actually give me a little bit of a lot of different resources in a single network request, right? Here, if you ask for genre lists, like 4x4 titles with certain properties on them, that'll give me just a little subset of all these different titles. And then I might create another endpoint called get title details, which will have an overlapping subset. And all of a sudden, you have more than the same data more than once in different URL and different resources. And that makes caching really difficult because if I want to make a change, now I can easily end up with stale data somewhere in my browser cache. So here we have the same information stored at 2 different URLs. And this is exactly what REST is designed to avoid. Because as soon as you have the same data in 2 different URLs, well, you might have a cache staleness problem. So with REST, we have cache consistency. It's so easy to cache REST. That's how your browser works. And we have loose coupling. I can build all types of new systems on this nice generic API, and I don't necessarily need to change the backend API. However, with RPC, we can have small message sizes. I can have requests that contain just the data I need for a particular view, and I can also have low latency. Instead of having to make several repeated requests to the same URL, multiple URLs, just to show one view, I just make one request and then I show that view. But what we at Netflix wanted, we wanted the best of all worlds. We wanted to be able to take those great things about REST, the very dependable and predictable things, and the power of RPC with the small message size and low latency, and combine them somehow. And that's why we introduced Falcor. So what is Falcor? Well, I will start off by telling you what Falcor is not. Falcor is not a replacement for your database, for your MVC framework, or your web server. In fact, Falcor is middleware. It fits into your existing stack, whether you're using Mongo or SQL Server or Oracle or Node or Angular or React, and it allows the layers to communicate more efficiently and easily. So you will see that we'll be using Falcor both to communicate from the client to the server, and then we'll be using the Falcor library to communicate between your middle tier and your backend services. Now here's one very important detail about how Falcor works. It allows you to imagine all of your backend services. You might have several different web services or databases. Netflix has over 80. And envision them, view them from the client as a single JSON resource. And in order to do that, Falcor provides a special library, a special kind of router that you use on Node to allow you to synthesize all these different data sources into one nice, natural JSON model that you can view from the client. So that's a key thing to understanding about how Falcor works. You have one JSON resource on the application server that contains all the data that your application will ever need. And the best way to understand what Falcor really is I want you to think of it as the M in your MVC. But it's a little special in that it's an asynchronous model. So what do I mean when I say an asynchronous model? Well, let's take a look. Let's take a look at what happens in Netflix, for example, when you load the front page. Well, first we're going to take all the data that we have, as I mentioned earlier, in our back end, and we're going to visualize it as one graph, one JSON resource out there in the cloud. And so member.json, so that represents an individual Netflix member. And then we're going to use the Falcor library on the client, the JavaScript Falcor on the library on the client, to make it seem to our device like all the data out there on the cloud is sitting right there on the device. And just like you would do with an in-memory JSON model, your UI is going to query this model for data. Now, however, this model, as I mentioned earlier, is an asynchronous model. So when you ask the model for data, what it'll actually do is it'll take your request and it'll communicate it to the server. Instead of downloading that entire JSON file, which in some cases, like Netflix, could be gigabytes and gigabytes of data, we'll use the query string to retrieve just the portion of the JSON requested by the client. So notice there that we're using the query string. Then just that subset of the JSON will be sent down, and it'll be cached on the client inside of our async model, and then pushed to the UI, and the UI will display the data. So now let's say we select a particular title and we want to check it out. Well, the device, your user interface layer, will ask the model for some data. It'll forward that request onto the server, asking for just the subset of the JSON required. That'll be sent down and delivered to the device, but once again, it's cached. And so now let's say we want to check out related titles. So I click on the House of Cards related titles, and we make another request to the server. And as we go, notice that we're accumulating a cache locally on the client of all the data we've downloaded before from that JSON object out in the cloud. In this sense, it's just like a browser in the sense that when you get data, it gets cached locally. And that means when I decide to hit back, like here, for example, right? Oops, excuse me. Can everybody still see my screen there? Charles? Well, I'm going to assume you can, just in case I'll hear otherwise if I can't. Great. Yep. So now I'm hitting back here, and the device and the UI is going to request some data from our async model. However, this time it's cached, and it will just come right out. And then we immediately render the screen. And once again, we hit back, we request from the async model, the data is cached. Now, we as developers aren't even aware of this cache. We just asked our JSON model for data, and out it comes. So let's take a look at what it really means to build Netflix on top of Falcor. So first, a little bit about the Netflix model. The very first thing you have to do when using Falcor is you have to sort of design your domain model, because all it takes is for you to design your domain model in JSON, and then Falcor will make it easy to access that data in JSON format anywhere it is on the cloud. So first, we have to come up with a model, though. So here's our model for what Netflix is. Now, I'm sure most of you guys out there are Netflix customers or are at least familiar with the service. And when you load up Netflix, what you see is a list of genres like recently watched, new releases, horror, thrillers, etc. And each one of those genres contains a list of titles. And so here we have our list of genres, right? And each one of those in our genre list, each is another list. Each genre, excuse me, contains a list of titles. So here in this particular example, this is highly abbreviated. We just have a genre list with 2 different genres, each of which contains just one title. And that's what I'll be using from now on, this simple abbreviated model, so we can understand what it's really like to work with Falcor. So let's get our hands dirty and start playing with Falcor. So I'm going to do a live coding of a mini Netflix application with Falcor here. So here I've just written this helpful log that'll help me display any text I want as formatted JSON onto the screen. And the rest of the code I'm putting inside of a window on load. But now I want to call your attention to this model here. It's essentially just the model I just showed you on the PowerPoint. We have a list of genres. And here's our first genre. It's recently watched. And because the model is abbreviated, it contains only one title, which is Daredevil. And Daredevil, we see both has the name and the rating. So now we have the new releases genre, which it contains, once again, for brevity's sake, only one title, which is, of course, the excellent House of Cards. And I've given both of these a rating of 5. And now, here at the bottom, I'm going to use the log function that I defined earlier to print some data. Now, notice when we're working with in-memory JSON, it's really straightforward, right? We just keep looking up keys until we get the key that we want, and we just go ahead and log that. So let's give that a shot, see if we can make that work. Already got it up here, but here I'm printing Daredevil. So let's go back, take a look at this code. Sure enough, that is the name of the first title in the first genre list, and so we get Daredevil. So that's relatively straightforward, right? We all know how to work with JSON. Nothing to see here. We're not even using Falcor so far. But as you can see up here, I've already imported the Falcor library. So I'm pulling this right off the Falcor website. And that means I can start to use Falcor. So with Falcor, instead of working with your JSON data directly, you work with it indirectly with the Falcor model. So what you're going to see me do here is you're going to see me take this JSON object, and you're going to see me put it into a Falcor model's cache. I'm going to go new Falcor model, and then I am going to insert this data into the Falcor cache. So now we've inserted our data into a Falcor model, and we've just sort of inserted it into the cache ahead of time. Now, the API changes only slightly when you work with your data indirectly using Falcor's asynchronous model from when we work with it directly. In fact, I'm just going to make a slight change here. I'm going to make a slight tweak. So instead, I'm going to go model.get and pass in just the JavaScript path that you saw earlier as a string. And that's going to return me a promise. Notice earlier I said that this was an asynchronous model, and that's how that manifests. It returns us a promise. And then when we get our response, we go ahead and log that response. All right, so wish me luck live coding here. Oops. That's what happens when you live code, folks. Stuff goes wrong. Uh-oh. Bear with me. I forgot to switch my reference. Sorry, I was working on a dev version. I've taken the liberty of downloading the Falcor version earlier. And there we go. So now I want you to take a look at what was actually returned. In this case, we actually got the JSON subset, the subset of all the JSON data that contains what we asked for. In this case, just to get the same result as last time, I'm going to change this to the helper function for when we're getting only a single value, and that's get value. So if we reload now, we see Daredevil. So all I changed was I passed the JavaScript path to the get value method. That's it. And now we display the data. So this on its own, okay, I mean, what big deal, right? We took our JSON data, we put it inside of a Falcor model, and now we're working with it indirectly, and we get out a promise. I mean, frankly, it's a little more inconvenient to deal with data indirectly. So what are we getting out of it? Well, let's just do a little bit of an exercise here. What I want to do is, in addition to getting data, you can also set data. So let's try something out. I want you to imagine, in order to understand what the benefits of Falcor are, we're going to go through a little exercise. Now let's imagine this is the type of JSON message that your application, your Angular app, for example, might download the very first time when you wanted to display the Netflix data. But the way Netflix works is, let's say I choose to watch new releases. I see that House of Cards is a new release, and I choose to watch it. Well, the next time I load my application, you know what's going to happen? Instead of Daredevil being the latest title that I recently watched, it'll be House of Cards, right? So that will happen if I decide to watch House of Cards, and then I reload the application. Now we can expect to see JSON data come down from a server that looks very much like this, right? So that seems pretty reasonable, right? We have a JSON object. Now notice that the JSON actually contains the same title twice. And if this were really realistic, we'd probably have something like this, right? When you're getting data from a server, from a database, you typically have IDs. So now let's just go ahead and try this again. This time around, I shouldn't expect to see anything too crazy. Just now it's House of Cards, no longer Daredevil. But now, in addition to being able to get data, it's also important to note that in Falcor we can set data. So let's say I've watched House of Cards. I want to set the rating. It's a great title. In order to do it justice here, let's say it was originally recommended to me with a rating of 4, but I think it's a great title, and I'm going to go ahead and rate it 5. So notice I just change get value to set value, and then I take a path, and then I pass in a value. Now, what that's going to do is return a response to me, and just to prove that it worked, I'm going to go ahead and turn around and then get the same value out of Falcor, and go ahead and print that once our set function succeeds. Okay, so we're setting the rating of the first title to 5, and then we're getting it, and we're printing it out just to make sure it absolutely worked. Hopefully that works. Oops. Great. So We set it to 5 and then got it as 5. All right, that shouldn't be too shocking. But let's try something a little bit different. Let's do a get. And this time, I'm going to show off what Falcor can do. Falcor doesn't just work with JavaScript paths. It can actually accept ranges and multiple indexers inside of keys. And so for those of you who have used XPath, it's a little similar to XPath. So here, I'm not just going to get the rating. I'm going to go ahead and get both the rating and name of the first title in the first 2 genre lists. Let's take a closer look at what I did here. This should be relatively straightforward, right? I can put a range inside of here. And here, I'm going to grab the first title, but instead of just, say, grabbing the name, I can just put in a comma and ask for as many properties as I want. So now, after setting the rating of the first title in the first list, House of Cards, to 5, I'm going to go ahead and get pretty much the whole tree and display it. So let's take a look at what that looks like. Pretty straightforward, right? So we've showed that Falcor's get is actually pretty powerful. We can request multiple keys using both a list of indexers as well as ranges. But I want to call your attention to something. I don't know if anybody out there has spotted one of the big problems with working with JSON data directly and transferring JSON data back and forth between server and client. Well, notice what happened? House of Cards appears in here twice, but when I rated House of Cards in new releases, it didn't reflect the rating in recently watched. So now we actually show one of the big hazards of working with JSON data. And that's that most domain models out there, your domain model is almost certainly a graph. But JSON is designed to send trees. And so as a result, what happens is single objects get blown up into multiple copies. And then when we make changes to one, it's very hard to make sure that they're reflected in changes to another. Now, Falcor introduces something called JSON graph. JSON graph is a way of encoding graphs just using plain old JSON. It doesn't require any fancy technology. So let me show you a little bit about that. So Netflix's domain model is a graph, as I pointed out earlier. Here, we see that we have Friends twice in the same genre list, right? Friends can be both considered a comedy or a drama. And so as a result, we have this graph. But as soon as we decide to convert this graph into JSON, right, which is designed for trees, we see something happen, which is we end up with duplicates. Most applications out there use what I call the duplicate and identify strategy, which means that they copy an object and then they just make sure to include the ID along with it. Now, that works. At least we get to use nice, ubiquitous, easily recognized JSON to send data back and forth between client and server. However, it does mean that when that data goes all the way through the cloud and lands on the device, we've got to make sure to dedupe those items, lest we show stale data to our users by not propagating changes from one to another. So when we put it in the cache, it's up to the client to make sure to check that ID and then dedupe. Now, it's really hard to get that right sometimes. And that's why Falcor introduces the notion of JSON graph. So let me show you that JSON graph in action here. Not this annoying. There we go. So let's see what JSON graph looks like. Now, JSON graph is incredibly simple. All we do is we add one little concept. Well, there are a few concepts, but this is the most important. One simple concept to JSON, and that is the notion of references. So here, a reference is not unlike a symbolic link. For those of you guys out there who use the Unix file system, right? We know that the Unix file system is a tree, but we can actually insert a special kind of file anywhere we want in that tree. And all that file does is it contains a path to another location in the tree. And when you're evaluating a path in the Unix file system, if it comes across one of these special files, it basically treats it like a directory and then evaluates that path and jumps to another location in the tree. And so using symbolic links, we can represent graphs in an otherwise tree-like data structure. So the same concept applies to references, JSON graph references. We can insert references anywhere we want in the tree to any other location in the tree. And that allows us to store every object only once. So I'm going to make sure that only one copy of House of Cards exists in my entire JSON model. And that way, when I change its rating, I never have to worry about propagating those changes to multiple different places. Now you can take any JSON object and convert it into a JSON graph object in 2 easy steps. The first thing you're going to do is you're going to look around for every single object in your tree that has an ID property. And then what we're going to do is at the very top level, we're going to create a map called titles by ID, where we're just going to organize all of the titles in our JSON model by their IDs. So the key is going to be, of course, the ID here in House of Cards. I'm going to put in 346. And now what I'm going to do is I'm actually going to copy this into here. Now here, at this, oops, did I put in 345? I'm in 346. At this point, the ID is kind of redundant. So I'm just going to go ahead and remove the ID because we know the ID if we've gotten this far because we've got 346. Now, that's the first of the 2 steps required to convert any JSON object to a JSON graph object. Collect up all the IDs, put them in top-level maps organized by their type and their ID. The next step is simple. We go through and we replace every other instance in the JSON object with a location to its one and only one other location in the tree, the location where we want to store it. And this is just a regular JavaScript path. Check this out. We insert a reference. And now notice House of Cards exists only once in the tree. Right? And so now I'm going to see what happens if I repeat the exact same query that I ran last time. Now, the way Falcor works is that it knows, just like the Unix file system knows how to traverse symbolic references, Falcor knows how to traverse references. And by the way, just in case anybody out there is wondering what this magical $ref does, I'm going to show you because it's so easy. All this little ref function does is create a data structure that looks exactly like this. And it'll take your JavaScript path here, it'll parse it into multiple keys. So one for every key that you'd look up on the object. And so this function right here is just generating this, a parsed version of the JavaScript path with a little $type ref. So there's really no magic here. That's all that's happening. So I'm going to go ahead and rerun this, fingers crossed. What we should see this time, oops, little mistake. Well, it's not a mistake, actually. See, this data that you see right here is just metadata inserted by Falcor. Ignore that for the time being. By the time I'm just working on a built version, so this little property here will be gone when the version I'm working on right now is pushed to the server. But this is just metadata that we insert inside of the JSON for Falcor. You can ignore that. That's normally hidden and it's enumerable false. I'm just working on a developer version. So as you can see here, though, the important thing to note, pay no attention to this particular property here. The important thing to note is that we have rating 5 in both places. Notice we have House of Cards, rating is 5. So even though we only have it in one place in our tree, right? It only exists in one place in our tree, and I set it where it lives at genre list 0, title 0 rating, I set it to 5. Now, the change got propagated everywhere because it followed through the reference and arrived here and set it to 5. So that's effectively how JSON Graph works. It's a very simple algorithm. If we come across a reference before the last key in the path, in this case, we came across the reference here at genre list 0, title 0, what Falcor does is it jumps to the root and it evaluates each key of the path until it arrives at the location pointed to by the reference. And then it's going to evaluate that last key here, the last key here, rating, and that's what it sets to 5. And the same thing when it's getting, it follows references as it encounters them, just like Unix follows symbolic links. So now we know how JSON Graph works. It's really a very simple concept, just like the Unix file system. What we're going to do now is we're going to explore what's really powerful about working with your data indirectly through Falcor. So the advantage of Falcor being an asynchronous model, in addition to being able to work with your data as JSON graph format, the real advantage is that because it's asynchronous, you can move your data out there onto the network and not change the code that works with it at all. So I'm going to go ahead and I'm going to just move this back to a normal get. So let's just do a simple get value, say for the name of the first title, of the first genre list. Right, that's another valid query we can make. I wonder what the name of the first genre list is. This is get value, so I'm just going to So it's not, whenever you're getting one property, you can just use get value. If I rerun this, we see it's recently watched. Is that correct? Well, I go up here. Sure enough, genre list, 0, recently watched. Okay, now what I'm going to demonstrate to you is that we can take this data that I'm working with here locally inside of a web page, right? We've got no server component for this whatsoever. And I'm going to take all of this data and I'm going to go ahead and put it in the cloud. And then we're going to see that I can run the exact same function and not change any code. And it will just go across the server and pull that data out from the wire. So what we're going to do is we're going to use Node.js to host our Falcor data on the server. So I'm going to go ahead and open up this node file that I built earlier. Okay. And I may have, so just to go through this process from start to finish, I have a Falcor demo here. I'm going to bump up this font size. I've already prepared a package JSON, but let's go through it ourselves. Now, what this does is we're just going to go ahead and npm install the Falcor Router, which we'll see why later. Actually, excuse me, I'm going to start with Falcor Express. Falcor Express uses the Express server framework available for Node, and it's an integration between Falcor and Express. And I'm going to go ahead, and I think that's all I need to install. Technically, I think I need to install Falcor as well. So can install a Falcor. And now I'm going to go ahead and open this index.js file that I have right here. And forgive me, I've already gone ahead here and done some things. So I'm going to that for later. So the first thing I'm going to do is I'm going to go, so this now what you're looking at right now is server code. And what you're going to see me do is I'm going to go back to our HTML. So this is the browser code, and this is our server code. And notice we're just going to go through this line by line. At first, I'm pulling in Express. No surprise there. In fact, I think I need to actually install Express. And Express comes with a body parser, and that's all that is for parsing the body of posts. I'm not sure we technically even need it for this because we're just going to be doing gets, but I'll install it for good measure. And I think we already npm installed Falcor Express. So here we're creating the Express web server, and the Falcor server is the integration between the Falcor framework and Express. And we'll see how that works in a second. And here we're just setting it up to parse the body on posts. We're not paying no attention to this line. We're not even going to be using it. Now here's the important part. A lot of you out there have worked with routers before. Now, what a router does, and typically it runs on your web server, whether it's a Java-based web server, or in this case, a Node-based web server, what it does is it looks for patterns of paths, and then it executes code, right? And then in that code, you go ahead and you return some data. So I'm going to get to this piece of code in just a moment, but I want you to notice we're going to create this model.json, right? And that's where all of the data in our JSON model is going to live on this one model.json resource on the server. Now here is just a bunch of boilerplate code where we say this actually makes any file currently in the directory servable over the web. And so that index.html file that we just created is actually in the same directory as this. And so we're going to be able to access it over the web. And that means we won't have any cross-domain restrictions. We're going to go, as soon as we bring the web server up, we're going to access it this way. And then this just little piece of code just initializes the web server. So this is really the interesting piece of code right here. And I'm going to explain how it works in a second. So, but watch what I do. I'm going to go here, and we're going to take this Falcor model that we created for local use, and we are just going to cut it. I've just removed it. So now look, you can see the entire contents of the browser code right here in front of you. And I'm going to go ahead and I'm going to paste it right here into the Node server. So we've taken our code that set up our Falcor JSON model and we've moved it into the server on Node. Now all we have to do to make this data, which is now stored in memory on our Node server, available for querying from the client over the wire, is we have to do something very simple. We go ahead and we return our model as data source. Now I'll explain as data source in a moment, but it's very straightforward. Frankly, the data source is just an interface. And so as we'll see later, there are multiple different components that can serve data over the wire to Falcor clients. And they're all implementing this one data source API. So the model can be adapted to the data source API, which means it's just going to serve whatever happens to be inside of its cache whenever requests are made from the server to a client. And I'll show you how all that works. It's really straightforward. But notice the important thing is we took the data from the client, pasted it into the server, and now we're pretty much ready to start requesting the data. Now, the issue, of course, is that now we don't have a model anymore, right? We've got the same code that we had before. Problem is there is no model. So I'm going to create a model, but different than last time. Instead of creating a model that has an in-memory cache, or defining the cache property, I'm going to define the source property. And the Falcor HTTP data source component is what I'm going to use. So a data source, remember, this is the data source interface, is here, this is basically a proxy. Anything we request from the model is just going to get sent over HTTP to our node script. And so we're going to give it the location of our node script. And now, that's all I'm going to do. So what I've done effectively here is I've plugged our model in to the model over here on the node side, all by giving it this URL. And so here we have the Falcor middleware. We call it a data source route. And it accepts the request and response object. And its job is just simply to return a data source. And so we've adapted the model to the data source. So hopefully this works. Live coding can be fun, people. So bear with me. We should be able to start up our node server just like this. Whoops. Got to npm install Falcor, or pull in Falcor. So I'm going to Falcor equals. So far, so good. That makes sense. And let's just make sure we actually installed Falcor. OK. And let's give this a shot now. Oops. We forgot to, when I was copying and pasting, I forgot to create the binding to my Falcor model reference. OK, so 2 errors, not so bad, hopefully. OK, let's check it out. Now, I just want to make sure that's the right address, localhost 9090. So when we get to localhost 9090, what should happen is the index.html, which is in the same directory as this particular index.js file. So the index.js file is our node file, and the index.html file is there. As soon as I go to localhost 9090, I should expect to see this index.js, which we've been running inside the browser, be served to me. So here goes. And we got recently watched. Check that out. So let's take a look at our developer tools. Ignore this 404. It was just for the favicon. It's because I haven't defined an icon for this particular website. But let's take a look at what actually happened. I mean, notice that although we took all the data out of the client, we still got the exact same response when I reloaded the page as I got before. So what's going on? Well, let's take a look at the network and find out. So notice we've got a remote request for data. Bear with me while I bump up the font size, folks. Let's see how Falcor works. It's really very simple. All it's taking is that JavaScript path. It's parsing it into an array of keys, and it's sending it over the wire. So here, what we saw is a query string. Right? You can see it's been URL encoded here, but all we're doing is we're passing all the paths that were requested over to the server. And as you can see, that URL, once decoded, just looks like this. It's just the list of the keys that we asked for. And what's happening all the way over on the server is that it's matching that against model.json right here. And it's routing any of those requests. It translates that, it parses that GET request out from the HTTP, and then funnels it to the model. And so it effectively executes the same GET on this model that we executed on it when it was on the client. And so that's the magic of Falcor. We get to code the same way because we're coding against an asynchronous API, regardless of whether the data lives on the server or on the client. And so let's take a look at what that server actually responds with, right? It's going to respond with just the subset, if we look at the response, just the subset of the data that we requested. So here we have our subset of data. Genre list 0, name. And ignore this little atom for a moment. It's not really important we talk about that. Long story short, it's a wrapper so that we can include extra metadata around the value. But as you can see, we didn't send back anything but the data requested. So let's take a look. Now that we've got Falcor talking to a server, right, I want to show off a couple of things about the way that Falcor works. Falcor, in addition to being able to basically not care about where your data is, what Falcor does, well, let me put this differently. In order to allow you to not care about where your data lives, Falcor provides 3 key features that are really, really helpful to optimize your client server communication so that you don't even have to think about it. We do all this stuff under the hood. I'm going to show you one of them right now. So here I'm asking for the name. So let's say I turn around and then I ask for the exact same thing again from Falcor. So as soon as I get my name back, I'm going to go ahead and I'm going to ask for the name again. Now, in reality, of course, you wouldn't do this, but later on in the code, you might do this, right? At some later junction, you might need the name again, and you might make another request for it. Well, if I run this, oops, I might have a little error somewhere. Bear with me, folks. Oh, did I console logged? We're going to log the name, and I'm going to log the name again using my special logger that inserts it into the web page. So this shouldn't be a big surprise, right? Prince recently watched twice. We asked for the name of the first genre list twice. But now let's take a look at what actually happened under the hood. Check it out. How many network requests do we have? Just 1. Load, so you can see. Might need to bump down my font size a little bit. Having a little Chrome problem, but long story short, I think you might be able to see here a little Chrome issue. I'll see if I can bring it back up. Having a little bit of trouble seeing my network tab, but rest assured, the point I'm trying to make is that the second network request never happens, only the first one. There we go. So we can see there's only 1 network request that goes out, even though we print out recently watched twice. Why is that? Well, it's because Falcor caches this fragment, every fragment of the JSON graph it receives, in a local in-memory cache. And so the second time we ask for recently watched, right here, it doesn't make a network request. It just goes and retrieves that same data from the cache, just like when you visit the same URL twice in a row in your web browser. So caching is one of the big features of Falcor. But let's say instead of making a request once and then making another request, we make 2 requests at pretty much exactly the same time. So I'm going to ask for the name of the first genre list. And while I'm at it, I'm going to ask for the length. Why don't we actually ask for something a little more interesting? Let's ask for the name and rating of the first title in the first genre list. So now I'm asking for 2 totally different fields, and I'm asking for them pretty much one right after the other. In situations like this, we probably want to avoid, if we can, making 2 network requests for 1 tiny little bit of JSON data. Where network requests come really close together, we'd like to be able to issue just 1 request and basically batch multiple network requests into 1. And Falcor allows you to do just that with a tiny little command. So I'm going to change this code just a little bit, and I'm going to call the batch method on the Falcor model. So by calling batch, batch, it creates me a new Falcor model. Actually, first, I'm going to run it without batch so that we can see this in action. And we should see, we see the name of the first title in the first genre list, and we see the rating of the first title in the first genre list. And notice that we see 2 separate concurrent network requests. Now watch what happens when I go back and I turn on batching. 1 network request made for both paths. So here you can see I've asked for genre list 0, title list 0, name and rating, all in 1 request. So batching and caching are 2 of the things that really allow you, Falcor, to optimize your network requests so you don't have to think about it. You just ask for data like it's in an in-memory JavaScript object, and you count on Falcor to optimize your client-server communication for you. Now, there's one final feature. This is really important. This is perhaps one of the most powerful features of Falcor for optimizing your client-server requests. So we've talked about batching. We've talked about caching. Well, the last feature I'm going to tell you about, Falcor uses the reference concept we introduced into JSON Graph, this right here, this notion of references, to optimize future requests made where you're grabbing more information from the same entity. So let's say when you're loading up the Falcor gallery, we just want to display a list or a bunch of box shots of titles. So the very first request I'm going to make is for name, right? And then later on, I'm going to request rating. So notice that caching shouldn't really help us here because, you know, we're asking for a totally different value the second time around, rating and name. And batching can't really help us here because we don't make the second request until the first request comes back. Nonetheless, Falcor is also going to be able to apply a really powerful optimization to even this type of pattern, which is incidentally is very common. Typically, you often see what are called, in Angular applications, master detail grids, where you list a list of items, and then somebody clicks an item, and then they drill down and you show them details about it. This is sort of capturing that very similar to that pattern right here, where I'm showing the name of a title, and then maybe if somebody clicked on it, later on, I would go ahead and show additional data about this title, in this particular case, the rating. So let's take a look at what happens when we run this. What we should see, in this case, just for, notice we didn't print out the name, so, oh, excuse me, we just printed out the name, so I'll log the name when we get it, and I will log the rating when we get it. Excuse me, there we go, that's a little better. And once again, we see the same thing all over again, but now I want to call your attention to the network request. So we see, as expected, 2 network requests because we're chaining these network requests. We can't batch them together because we're waiting for the first one to complete before the second one. So let's take a look at the first one. It's very much what we'd expect. We ask for genre list 0, titles 0, name. But what about the second one? Notice that what we asked for in the second request is genre list 0, titles 0, rating. But what actually gets sent over the wire? Titles by ID 346 rating. What happened here? Falcor took our request for data and it optimized it into a lookup by ID. How did it do that? Well, after Falcor, let's take a look at our first request and the response from it. Now, if I take this data, and hopefully we can maybe put it into a JSON formatter so we can see what it looks like. So notice, although my first request was for the name of the first title in the first list, instead of just sending back House of Cards, Falcor actually sent back all of the references that it encountered along the way while evaluating the path. And so by the time this data had been downloaded and it was in my cache, when we attempted to look up genre list 0, titles 0, rating, Falcor came across the reference. Falcor essentially uses references to learn about your graph and learn faster routes through your graph. So you don't constantly have to be thinking about whether an API accepts an ID or whether it accepts an index or a page. Everything just works under the hood. It recognizes IDs and it optimizes your query. So instead of genre list 0, title 0 rating, it became titles by ID 346 rating. Why is that so important? Well, it's much faster to look up things by ID on the server than it is to look up things by relationship or by page. And so by Falcor doing this automatic ID optimization for us, it really makes things easy. So the last piece I want to show you is that although so far with this exercise, we've shown that basically Falcor allows you to code the same way no matter where your data is on the cloud, and it uses caching, batching, and path optimization, this process of what we call path optimization, to make that fast without having you think about it. So far, I've only showed you how to access data that's sitting right there in memory on a node server. Now, if you're like me, you probably don't store your data in memory on a node server. You store it in databases like MongoDB, or maybe you access it through a service layer, right? So, I mean, how useful is this really? I mean, being able to put our data in memory on a node server. In reality, what we want to be able to do is we want to store our data in back-end data stores like MongoDB and SQL Server. So how do we move it out of in-memory here and into a server? Well, we're going to use a specialized component that comes with Falcor called the Falcor Router. Pull that in here. Now, a Falcor router is very similar to a traditional router in the sense that a traditional router matches URL paths and then executes some code and returns the data. A Falcor router does the exact same thing. It matches paths. But notice that all the data that you retrieve from Falcor is actually located at a single URL. So what do I mean when I say the Falcor router matches paths? Well, it's simple. When you request data from a Falcor router, you pass in JavaScript paths, right? Paths like this. And a Falcor router matches patterns in the JavaScript paths you asked for. And then it goes to your backend service, retrieves the data, and then returns it. So that means that you can keep your data wherever you want. So I'm going to go ahead and create a new router. And the Falcor router basically just accepts a list of route objects, where each route object is a path. So I'm going to match a I'm going to match a path genre list 0 dot name. So if somebody makes a request for the name of the first genre list, and then I'm going to pass in the handler for when that path succeeds, my get handler. So you can execute one of 3 different operations on Falcor. We've seen get, we've seen set. The last one is call. We don't have time to cover it today. So this is just where I'm going to, this is, in other words, if somebody tries to get genre list 0 name, it's going to execute this particular function. And my job is very simple. My job is just to return the path and then the value for that particular path. So here I'm returning it the path in the parsed array form, where it's just an array of keys, and then the value. And so we know that, you know, the value in our document today, the value is of the name of the first genre list is recently watched. So I'm just going to spoof that here, recently watched, and I'm going to now, instead of returning this model, which has an in-memory cache, the secret to the Falcor router is that, like a model, which can be adapted to the data source interface, a router is also a data source. So what a router is, another way of thinking about a router, I'm going to replace this model with our router. Another way of thinking about a router is it's a data source for a JSON graph object that's virtual. It doesn't really exist in memory, but instead when somebody requests a piece of that JSON graph object, we dynamically, lazily create it. In this case, I'm just putting in the data, but normally here's where you would insert your code to go to MongoDB or SQL Server or whatever your favorite database is, and then return the code. And all you have to do is return this little tuple of both path and value. So if everything goes well, we should be able to now make a request for the name of the first genre list. And even though that value doesn't exist anywhere in memory on the node server, it should just work. Here it goes. Recently watched. So once again, that value gets remotely sent over and we get data back, but this data wasn't actually pulled out of memory. It was dynamically created when this function ran here on the node server. So this function actually got run, and we returned this, basically this both path and value. And it converted that into a JSON graph object and sent it over the wire. Now, it's not that much fun to have to create different routes for every single possible genre list 1, genre list 2. And so that's why Falcor provides patterns. So here I can match any genre list, right? And so I can say and what this looks like is it takes the path that's actually passed in and it parses it into array format. So once this comes in, it'll look something like this. This is just so that we don't have to do any parsing, for example. Because you can match multiple paths in a single shot, we're actually going to get an array of possible keys here. And so I'm going to put in, and it's going to come back looking like this. And so I'm going to go ahead and actually I can even give this an alias, IDs. So I'm going to say IDs for each ID passed in, in order to get that alias, I just go passset.ids. And here, if the ID is equal to 0, we'll return, I'm going to create an array. I have to create an array of path values to return, because now I'm going to return multiple path values. And if the ID, or excuse me, I shouldn't call this IDs, I should call it indices, right? Because it's indices, they're not IDs. These are indices in the list. So if it's index 0, we do this, and else if it's index 1, we're going to return new releases. And just to prove that there's no shenanigans here, I'm going to get rid of all this data right here. So the model isn't even in memory anymore. Right? And finally, after I built up my array of path values, because basically, in order to make things efficient, this particular pattern can match multiple paths. Remember, in a single request to Falcor, you can pass multiple paths. You can ask for as much or as little data as you want, and that's why the route can match multiple paths, so that we can make one request to our database to serve multiple JavaScript paths. So I build up an array of these path values, and finally I return it. And if everything went well, there should be one right here. If everything went well, we should then see both recently watched and new releases. I'm going to go down here. I'm going to change this to genreless 0 to 1 name. So we grab both of these at the same time. And since I'm grabbing multiple values, I can't use get value. I can just use get. Response. And let's see this work. And sure enough, we get the data. Now, I don't have time to show you the actual process of getting the data out of your database, but really it's this particular piece of code right here where you would insert the code that looks at the path that was sent in, right, which in this particular case is going to look like this. And then you can make a request, say, for a page from your database from 0 to 1, right? You can instantly envision how just by inserting your code here, you can write code that goes to your data sources, maybe more than one data source, and converts the result into the format of the JSON object that you have, and then returns the data. And that's how Falcor basically moves data from in-memory on your client all the way into your backend services. But you as an Angular developer, or when you're working on the client, you don't need to think about all that stuff. All you know is that you have a JSON resource out there on the server, and you're just requesting pieces of it and displaying it on screen. Under the hood, Falcor will cache it, it will batch it, and it will optimize your requests into request by IDs for you. It basically takes the pain out of data access. So let's take a look at what we did. We built a routed model, right, where I didn't have time to show going to all 3 databases here, but that's actually how Falcor works. We get this one member.json, and then we match the paths for various pieces in the JSON and go to totally different databases. And that gives us the caching benefits of REST, but because we can send as many JavaScript paths over the wire on a single request as we want, we also get the low latency and small message sizes of RPC. And I didn't have time to talk about it today, but Falcor also supports function calls for those non-idempotent operations like where you're adding to lists or removing from lists, for example. So let's say I want to show a detail view for Netflix. Let's say you click on an individual item. Well, your controller sort of, like what it can do is it can create a Falcor model bound to a particular location. And then in Angular, in the new version of Angular 2, you can use the async bindings to bind your templates directly to the Falcor model. So using this technique right here, you're going to be able to use Angular 2 to bind directly to the async model. So the fact that it's an async model doesn't really disrupt your programming model very much at all, because thanks to Angular 2's declarative async binding, you can bind directly there. Now, this will, of course, issue multiple requests, but they'll all get batched into one using Falcor's batching. And then we'll make a request to member.json, and we'll optimize those requests into requests by IDs if we already have the reference. We'll send back just the piece that we need, and then the view will output HTML. So there's a little image missing here today, but currently Netflix uses Falcor for every single one of our modern platforms. So whether you're on an iPad, or whether you're on a phone, or whether you're on the desktop, or whether you're on your TV, Falcor is the way that Netflix communicates with the server. And Falcor is available now. Oops, this is an incomplete URL. Check out the website at netflix.github.io/Falcor. And definitely follow Falcor.js on Twitter, as well as this is my Twitter account, Husain. And Michael B. Paulson is our lead developer. He's doing some amazing work on Falcor right now. Definitely check him out. And I'll just, I think I'm almost out of time, but I'll just show you the website here. We've got a lot of great documentation on the website. Go ahead, try us out. Tell us what you think.
All right. It looks like we have a few questions. It is 4:30 Eastern time. So if you need to take off, Jafar, that's fine. Otherwise, we'll run through some questions.
No, I can hang out.
All right, cool. The first question is, does this cache on the browser between page loads, or is this best for single page apps only?
Falcor is really designed for single page apps. However, it's very easy to take the Falcor cache and dump it to local storage if you have a multi-page app. So right before you leave the page, you can take the Falcor cache, dump it to local storage, and then restore it on the next page.
All right. The next question is, can we manage the cache and make it not pull too much data onto the client?
Well, by default, Falcor's only going to pull the data that you ask for into the cache. Now, that said, you can always get rid of that data from the cache in two ways. One is on the server, you can attach metadata to the values when they're sent over and basically tell them when you want them to expire. And you can have them expire immediately, for example. Likewise, on the client, you can also manually invalidate data from the cache. So you can just call model.invalidate anytime you want, and you can get rid of it on the client side.
All right. Are there limitations to using onboard caching on memory-constrained devices?
Yeah, that's a great question. And it's actually a big problem that we have at Netflix because some of our devices are relatively inexpensive set-top boxes with not a lot of memory. And the way we make our application scale from those tiny little devices to the next-gen console is with a trick. We keep all the data in cache in a LRU, in a list, and then it will allow you to give a maximum size to the cache. And whenever you go over that maximum size, we just clear it out of the LRU. And that means if you ask for the data and it's been purged from the cache, well, fine, you make a network round trip. But if you ask for it and it happens to opportunistically be in the cache, great, less latency. So you can keep your data within a certain maximum bounded amount of memory.
And for those who aren't familiar with the term LRU, that's least recently used.
Right, so least recently used queue. So that means every single time you ask for an item, it becomes the most recently used, so it gets bumped to the front of the queue, and then you're less likely to collect it during a cache collection phase when you elapse the maximum size.
Right, so then you drop the stuff off the bottom, which was least recently used.
Exactly.
Okay. Search path in strings, it can be hard to find bugs. Is there a way to pre-process them or express them in a DSL that can be linted?
I think it's fair to say that where paths are in strings, you're going to have. I mean, it's definitely going to be. You're going to have less ability to analyze that at compile time, right? So, I mean, frankly, it's just like working with JSON, right? And if you're working directly with JSON data that comes over the wire and you don't have a type schema for it, it's definitely, you're going to have all the positives and negatives of that approach. Some of the positives of working directly with JSON and not having a schema in advance is that you can actually make certain interesting schema changes to Falcor without actually changing your client code. And I'll give you a good example of that, which is that initially when I started Netflix 3 years ago, when you accessed your genre lists, while you were using it in the UI, every 4 hours or so, we would refresh it underneath you. And that could lead to data inconsistencies because, you know what, you could be browsing in one particular list, but because the actual genre list contents changed underneath you, you could all of a sudden start to see what we call page tearing, where one page comes from one list, but then another page comes from a different list. And so you might even see the same title in there twice. We really wanted to avoid that. And so what we did is we actually introduced a reference. So instead of just going genre list 0, when you went to genre lists, we created you a genre list, put it in an EV cache, and cached it for long periods of time. And then when you went to genre list, we would refer you to, using a reference, we would refer you to genre list 526951. And that, just by using the fact that Falcor automatically optimizes all paths to any references it follows, we were able to make a schema change on the server, not have to change any client code, and introduce a completely stable list of genres just by introducing a reference. So there are positives and negatives to having schemas set ahead of time.
All right. The next question is, are there any instances where you'd want to operate over multiple endpoints? It seems like paths make the name of the endpoint largely unimportant.
So in fact, I would say this is probably one of the most important set of Falcor's constraints, which is you definitely would not want to operate over multiple endpoints. As soon as you have multiple endpoints, all of the problems of REST come roaring back, right? Maybe you get some of your data from one endpoint, but then it's referring to data which is in another endpoint, and then now you've got to make a round trip call all the way from the server back to the client. Remember, that big hop from the server to the client is like, you know, the hop from the server to your database is like, you know, getting up from the table and walking across the room. But the hop from the client into your network is like flying to China. That's the really expensive cost you want to avoid. And by making all of your data available at a single endpoint and doing all of by walking references on the server instead of HTTP redirect, which is, by the way, the REST equivalent on the client, it's much lower latency. Refs are sort of like a mini version of an HTTP redirect. But the thing is, because we guarantee all the data is available at this one URL, we know for certain that we can follow those references on the server. We don't need to send you back the equivalent of an HTTP redirect on the off chance that you might have to go to an entirely different server to get your data. And that's what's absurd about modern REST services. They will often send you back redirects where you just end up jumping right back into the same network to get the resource. And that's what contributes to the high latency. If you're not building a massively distributed application where you're going to 17 different services and across 17 different companies to retrieve your data, which such mashup type applications exist, then there's really not a lot of value in having the flexibility to put your data on a bunch of different servers. But if you are, then maybe Falcor is not the right choice for you. In our experience, a large portion of web applications just find themselves going back to the same server again and again and again. And so references allow us to optimize that client-server interaction.
Cool. How can you invalidate the Falcor cache, for instance, if data on the server is updated?
Good question. So out of the box, Falcor doesn't support push. However, and it basically has the same mechanisms which is that we use today with the web, which is TTL, so time to expire, excuse me, where you can send back an expiration time with a piece of data, and after a while, the Falcor cache will just purge it once it elapses that time. And then you can also manually invalidate on the client. Now, it turns out, though, that the ability to manually invalidate on the client is actually all you need, because if you've got a WebSocket, we'll just go ahead and push messages, paths essentially, to the client, and then have just call model.invalidate and get rid of those paths. That's effectively the way we're planning to take on these types of push notification systems at Netflix. Of course, if you've got a WebSocket or you want to do polling, one of those two mechanisms, all you have to do is call model.invalidate, and then you effectively have the equivalent of a push system.
All right. Are there going to be Falcor libraries for other backend systems and/or languages?
Well, so people have already actually worked on a preliminary .NET version. There's an early developer preview release written in Go for the router released already, and I'm sure people are working on routers in other languages as well. I know internally we're working on a Java version of the router. So you can definitely expect to see more routers arrive over time. And what was the other question? Was that the only question?
That was it.
Yeah. Yeah, there's lots of people who are interested in porting Falcor to other platforms. And if you are one of those people, definitely reach out, and we'll give you any support we can.
All right. I don't see any other questions in the system. So thanks for coming, Jafar.
Thank you.
All right. If people want to learn more about, one other question I was going to ask, if people want to contribute to Falcor, can they do that, or do they have to be Netflix employees?
Absolutely. Falcor is open source, Apache 2 licensed. Go check it out on GitHub right now, and submit your PR, and we'll be happy to take a look at it.
All right. Well, thanks again. And yeah, this will wrap up day 2. Yeah, we'll see you all again tomorrow.
Thanks, everybody.